it's time to talk about the tools of the trade. So we're going to start with what may well be your best friend. This is an old school incandescent test light. This thing is worth its weight in gold. And these can be had for, heck, you can find them in that bin they have by the checkout thing for, you can get a cheap one for a couple bucks. But the better quality one is worth the extra money. Now, this one is incredibly high quality, has a nice springy lead and a really good sized clamp on the end. This is a really good one, but anything will work in a pinch. Another thing is voltmeter. Now, you can use an expensive one, or you can use a really cheap one. And these can be found really, really cheap. I keep this one as a spare. Now, the difference between a good one and a cheap one, the biggest difference, this one, you can drop it a few times. I'm not sure how many drops you'd ever get out of this thing, and maybe one good drop and it might be done. Also, the leads. This has really high quality leads with, this uses a standard size banana plug, so you can get replacement leads for it. This one uses a weird size plug. If you break a lead, then you're going to have to fix it yourself. Another addition that you should do if you ever intend to use this 10 amp terminal is you should mount an inline fuse in one of the lines, because sometimes these units are internally fused, sometimes they're not. But if you forget that you're on 10 amp and you go to check a voltage across a battery, you're going to, at best case, blow the fuse. In the worst case, melt part of the circuit board. So put a fuse in it, and don't go over 10 amps. And use a good quality fuse, not these bargain basement things that you get at where it's got like 200 fuses for 10 bucks. Don't do it. I've tested these things, and I had a 5 amp fuse blow at 15 amps. Don't go there. Next, bottom of the line scanner. Cheapest one you can find. Even the cheapest one will give you your generic OBD2 codes. Most of them, while they may not provide a definition of the code, they will give you the code, in which case you can Google it, look it up in a manual, you can figure out what it is the computer's saying that it doesn't like. Now, this thing is wonderful. This is a scope, and a scope can do things that it'll blow you away once you figure out what you can do. This one, I think I paid $35 for it. It's a single trace. It's not a dedicated automotive scope, and that's a good thing, because things can go south pretty quick. Now, this image here was taken with a $2,000 scope attachment on a Genesis Evo scanner. And you notice the nice pretty square wave? Now, I had a gut feeling this car had a bad crank sensor. This is what showed up on the other scope. That's not a nice clean square wave. that sensor was breaking down. And, you know, I don't like automotive digital storage oscilloscopes because they can make up good patterns. Now, a pair of jumpers always comes in handy. And jumpers, to be really useful, you want to use like, I find these 16 gauge jumpers really handy. And at any hardware store, you can buy the alligator clips and buy the wire, make your own set, or you can buy them. Another thing, very important, for both voltmeters and scopes is a back probe. Now, this, as you can see, it's a paper clip that's been sharpened on one end. And the way you use this is to, without damaging the wires, you take this and you shove it in between the insulator and the wire, and you get your contact that way without damaging the wire, and you can monitor whatever is on that circuit. Okay, so you want to fix some stuff? This is all the stuff that I keep in my electric toolbox. Aside from it, there is one thing missing here, and that's the heat gun. And you can use a Bic lighter on these shrink connectors, which are the ones to use. But you can leave soot on the connection. It can look ugly, and a heat gun does such a pretty job. But if you're in a tight space under a dashboard, sometimes the heat gun is not the way to go, because you can damage other components. Have some wire, some 18 gauge and some heavier wire, 16, 14, 12, or 10 can come in very handy. Another thing, old connectors. If you have, say this connector has a broken wire on it, well, you can release the pin out of one connector and solder it up to your broken wire, and you can get back that good connection that you need. So anytime I do something where I have a piece of harness, I just clip off the connectors and save them in the junk drawer. They come in really handy. A knife for cutting tape, zip ties, whatever. Utility knife works really good for that, but as usual, I couldn't find mine, so I used a multi-tool here. Then, shrink tubing. The good stuff has a glue in it that when you heat it, it'll ooze out the ends. That's the one you want, because that actually weather seals things. Also, butt connectors. Don't cheap these out either. Now, these are the ones to use. You hit them with a heat gun or a Bic, and you can melt the, shrink the insulator there and make a completely weather-tight connection. Also, difference between a good connector and a bad connector, the wall thickness of the insert. You want one with a thick wall thickness. The cheap ones, they pull out. Solder in a soldering iron, some tape, and then the crimp tool. You want a crimp tool that has a die like this, where when you clamp the wire in there and clamp down on that, it's going to make a positive connection. You're essentially cold welding the wire to the connector. Also, this comes with a really good stripper. Now, this particular thing I bought off the Snap-on truck. I think I paid like $35 for it 15 years ago. it's a great tool. And then, last but not least, we go back to the laptop. A cheap laptop can come in really handy because of the stuff that you can download. And of course, it's choosing now to be in a bad mood, probably because I need to install an update. Okay, here we go. You can download, quite often, factory manuals. And this is a cheap old laptop that I put Linux on because Windows Vista is no longer supported. And for stuff like this, this is a PDF file. It works great. Okay, this is Automotive Electronics Take 2. Let's see how this one goes. Welcome to my course on automotive electronics, to take the mystery out of electricity when it comes to working on cars. My hope is to give all you gearheads enough knowledge to not be scared to death by wiring diagrams and be able to actually do some simple troubleshooting and understand how your systems work. And if you understand how it works, you can figure out why it doesn't. Now, the first thing you got to do is you got to learn the lingo. There's a language to electronics. Now, this chart here gives you all the equations of Ohm's law. So if you want to know the item in the center, then if you can find out what the other two things that you can know are, then here are the equations to solve that. Most of the time, you'll see those equations expressed. The only one that comes out the same is voltage. Now you can think of voltage as pressure. So figure we got a tall water tank here, the amount of pressure at ground level, that we can think of as our voltage. Then we have current. For some reason, most explanations of Ohm's law use the letter I for current. Well, I'm going to use the letter A for current because current is measured in amps. And think of the amps as you've got a valve open on your water tank now, and the amps is the amount of water that's coming out. Not how hard it's coming out, but the amount. Then there's resistance, which is given by the letter R. I prefer to use the universal symbol for resistance, which is omega in the Greek alphabet. Anyways, you can think of resistance as the amount that the valve is open. And the fourth part of the equation is power, which is, they use P in expressions of Ohm's law for no reason. I prefer to use W for the watt, named after James Watt, inventor of the steam engine, among other things. And you can think of power as the amount of work done, like how much water you manage to get into the bucket, overcoming the resistance with the voltage and producing the current. Another thing that I didn't cover here is the relationship of horsepower to watts. horsepower, also invented by James Watt. Now, the number that is accepted is 746 watts to 1 horsepower, and that's what's used to rate electric motors. If you look at the label on an electric motor, you'll find that if you do the math, if it's a 1 horsepower motor, it's going to be about 750 watts. If it's not expressed in watts, you can use Ohm's law and figure it out from the current, but it'll be the same. I can't figure out how they came up with that number, but that's the number that's universally accepted, so we're going to live with that. Okay, if you're feeling Egyptian enough now, it's time for some hieroglyphics. Okay, we're going to start with the battery. And that can be represented with this symbol on top. Now, if you go down below there, you get to a capacitor. Now, the top one is a normal capacitor, and it doesn't care which way you put it in. The bottom one is what's called an electrolytic capacitor, and it does care which way it's installed. Now, most electrolytic capacitors will be identified with a plus or minus on the positive or negative end, or they may be packaged in such a way that they, like an ignition condenser, where it can only be installed one way. Now, next we have the resistor. And resistors have a multitude of uses. The most familiar one would be the ballast resistor, which cuts down the voltage to the coil. And then below that is the diode. And there are diodes just all over a car. And some of them you notice, some of them you don't. Now we have switches, which in the simplest form are represented by a simple arrow with a dot next to it. The second one is called a single pole double throw. That is a single switch handle that operates 2 internal switches. These are very common. Window, mirror switches tend to work this way. And the bottom one is a rotary switch, which can be depicted in a lot of different ways from looking at various vehicle diagrams. It can be a straight line between the contact points. They're all over the place as far as how they're shown on a wiring diagram. Next is the solenoid, or relay. Relay is actually the correct term, but we tend to call the little ones relays, and then when they get big like this, we call them solenoids, but electrically they do the same thing. They use a low current switch to switch a very high current, and that's what the contacts are. Now you'll notice that there's an NC and an NO. Many relays will conduct in the closed position, and they'll have an NC terminal, or they'll conduct in both open and closed, where they'll have an NC and an NO terminal, or they can only function in the normally open position, in which case the NC pole is not there. Now also, if you look over to the side, you see a resistor and a diode there. Sometimes a relay may use a resistor or a diode to prevent a voltage spike from going back through the system. In the event that they use a diode, then the polarity of the low current power is important. But If they use a resistor, then it doesn't matter whether you whether you switch the power or the ground. Next we have bulbs. Typical incandescent bulb, like an 1156, 194. Then we have a double element bulb, like a high-low beam headlight, or an 1157 brake light, or any number that's generally followed by 57 for a double element bulb. And last but not least, we have the light emitting diode. Now, the light emitting diode, being a diode, will only produce light if hooked up in the correct direction. If you hook it up backwards, it will do nothing. It won't melt the wires, it just won't do anything. Then we have rectifiers. Now, a rectifier, you take AC in and you get positive and negative out. Now, a lot of battery chargers will have a half-wave rectifier, which is what's shown here. The one half of the AC goes to the case of the unit, and the other half of the AC is split by diodes into positive and negative. Below that, I have a full-wave bridge rectifier, which the AC is put in two ends, and you get positive and negative at either end. Inside an alternator, you generally have banks of 3 diodes that connect to the windings of the alternator, and these diodes all together are called a rectifier. And the windings can either be in the delta, where the AC comes off the points, or it can be a Y, where the AC also comes off the points. But in either setup, you have 3 wires. So something for real nerds there. A car actually produces 3-phase. Now we have the transformer. Now, transformers are not used an awful lot in cars. Well, there are not a lot of transformers in a car, but they're very, very important because the ignition coil is a transformer. You have thick, heavy windings and relatively few windings for your high power. And then to get your super high voltage, you have fine wires and lots of windings. And what this does is the magnetic field produced by these heavy windings, when it breaks down, it sends voltage through the fine wire, and that's what fires your spark. Now, as you see by the red line there, in the case of a typical automotive coil with a distributor, the primary and secondary are tied together, so you only have 3 connections, being the coil wire and your positive and negative wires.